Okay, so just like yesterday's warm-up, we are going to solve this, and we're going to give our reasons for each step off to the side here. So your first step is that this equation is given to you, okay? So if you're given an equation, first step's easy, it's given. From here, we're going to start doing some math. So if you have a number in front of a parentheses, what do I do with that 3 and this whole parentheses? Okay, multiply, but it's this fancy word. This is called distribution. Remember that word? Maybe? If you have a number in front of a parentheses, you're distributing into the parentheses. I like to show that with these little arcs like this. 3 times x, 3 times 2. Okay, so 3 times x gives me 3x. 3 times 2 gives me 6. Bring down equals 12. Now, again, what did I just do? Distribute, okay? So I'm going to put what off to the side? Distribute, okay? I distributed, okay? That's fine. Next step, if I'm solving for x, 3 and 6 are on the same side. What do I need to get rid of first? The loner, the positive 6. I got to do the opposite. What's the opposite of positive 6? And if I subtract on both sides, I'm going to write my step off to the side here. So 12 minus 6 is 6 because I subtracted on both sides. Last step, to get rid of that 3 in front of x. It's a coefficient being multiplied, so what do? What's the opposite? Division, divide by 3, divide by 3. So x equals 6 over 3, which is 2, right? So I divided on both sides, okay? Now, this stuff should be old news, stuff you've done a little bit here, hopefully in Algebra 1. If not, you're going to have to get used to it because we're doing it this little mini unit. The new thing is you're given your reasons, okay? So I was given this one, then I distributed, then I subtracted, then I divided, and I got my answer, okay? So on today's notes, which you should have in front of you that you grabbed on the way in, that's what you're doing, okay? Cool. So here we go. We're gonna start these notes on algebraic proofs. Everyone's looking at this sheet. We're gonna go on this line by line. If you can't see because of a glare, let me know so I can change the lighting. But can everyone see this? Okay. It says at the top, a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Algebraic proof. You use proofs all the time in Algebra 1 without even realizing it, and I'll show you today. Here's our properties. We're going to fill in the name of the property below from the word bank provided. At the bottom of your page, there's a word bank, right? We're going to fill all these in on the left-hand side here. So the first one, hold on. Try to zoom that in. There we go. Okay. The first one is commutative property. Okay. If A plus B, if you have A plus B, that also equals B plus A. You can switch the order of terms if you're adding or if you're multiplying. Not dividing, not subtracting. Okay. And you'll know this. For example, 1 plus 2 is 3. Flip it around. 2 plus 1 is also 3. Same thing, right? You can commute. You can move them around. Okay, second thing is the associative property. You can associate tiles change where the parentheses is. So that's associative. It's the same three letters, A, B, and C, but the parentheses changed position. Okay. Okay, so that was the second one, associative property. Now, this is what we just did this morning. If you have a number outside of a parentheses, you're going to multiply it into the whole parentheses. What's that called again? Yeah, distributive property. Cool. So again, if you multiply into a parentheses, distributive property. The next one, if you have two things that have a similar term, x and x, you combine them together, that's called combining like terms. We've done combining like terms before. Okay, if you have more than one x or more than one number, you can combine them together. Combining like terms. Now, this one's weird. A equals A. If any number is given to you, it equals the exact same number. Duh. 5 equals 5, 8 equals 8. But there's a name for this, and it's called the reflexive property. Okay? So, reflexive property means that something equals itself. Every time I move it, it does that. My apologies. Okay? So, reflexive property is next one. Think about it this way. Okay? If A equals B, B equals C, then A equals C. Okay? I'm trying to think of an example of this, but anyways, imagine A equals B, that same B equals a third thing C, you kind of skip over the B and say A equals C. Okay, that's called a transitive property. Okay. All right, and then the next one, if A equals B, you can substitute anything in, sorry, the B can be substituted for A in any expression. Okay? So anytime you substitute, it's just like it sounds, substitution is substitution. Okay, your substitution property. Okay. Next one. Now look at this. If A equals B, then B equals A. What happens when you flip it over? Think about it. If it's the same on both sides, you can flip it over. Now think about this. This is a geometry term. If I have something that I can fold down the middle and it's the same on both sides and you fold it in half, what's that called? Y'all ever heard that word? When you can fold something in half and it's the same on both sides? Y'all heard the word symmetry before? Maybe? Like one of these hearts, not a human heart, but like a Valentine's heart or a circle or a square. You can fold it down the middle, fold it in half, and it's perfect, right? Same on both sides. So if it's the same on both sides, you can flip it over. That's called the symmetrical property. Okay? Symmetrical property. If you flip an equation over, A equals B, then B equals A. Okay? Okay, last four. These are the last four, and they are the four operations that we use in mathematics. Okay? So if you add the same thing on both sides, that's going to be addition. Subtract the same thing on both sides, that's subtraction. You multiply the same thing on both sides, that's multiplication. If you divide the same thing on both sides, that's division. Okay. So that's what it looks like for the last four. Adding on both sides, adding. Subtracting on both sides, subtracting. Multiplication, division. Hit those last four down, please. That's probably the most important part of this, but sure. I know. It helps if you're here. Sorry if that's too zoomed out. So those are all of our properties. We're going to use these properties when we're solving equations on the next page. So go ahead and get those down and then flip it over. All right, next page here. At the top, it says now we can begin writing algebraic proofs, okay? Now, yesterday's warm-up and today's warm-up is kind of basically what we're doing. Solve it, give me a reason. That's it, okay? Each proof begins with given. Why don't you circle that? What does each proof begin with? What does each proof begin with? Given, hey, okay? And let's see here. In a two-column proof, you list the steps on the left and then the reasons on the right. That's pretty much it. Now, these two examples on this page are kind of like training wheels. I give you all the steps on the left. You tell me the reasons on the right. That's it. So you kind of just follow along, right? Everyone's head up, looking over here. So, number one, what is always going to be your first step? Ladies and gentlemen, what's my first step going to be? Given. Every time. Every time. Given. Number one. Okay? So go and write that down for number one. You can see it right here, and it's right there. It's given. First step is given. Now, from there on out, you're telling me what happened. What happens next? What happens next? All right, so let's think about this. Step one to step two. What's the difference? What changed? Step one to step two. What changed? Okay, so y'all see the parentheses went away? Okay, when the parentheses go away, typically we're dealing with distribution. So I know you're multiplying 2 times x and you're multiplying 2 times negative 3, but since it's in the parentheses, we call that distribution. And if you remember from the front page, it's called distributive property. Distributive. Now, from step 2 to step 3, what changed? What went away? Okay, that minus 6 went away. So you want to think, how did they get rid of a minus 6? What's the opposite? Yeah, adding 6 on both sides, right? And doesn't that make sense? The 8 plus 6 on the right side makes 14 for step 3. Works out. So since I added on both sides, what's my reasoning here? Addition. Addition property. Okay. Last step, when I have 2 in front of x, that's a coefficient that's being multiplied. What's the opposite of multiplying there? Division. So I divide on both sides, divide by 2. 14 divided by 2 does give me 7, right? And that's what I was trying to prove, that x equals 7. So that worked out. So since I divided on both sides, what do I write? Division property. Now, if you put something else like dividing or something, I'm okay with that, okay? But technically it's division property. That's super ugly. Forgive my handwriting here. Sorry about that. Now, let's look at number 2. Has everyone got the first one down? I'm just doing it step by step, giving my reasons on the right, okay? Number 2. Now this one's kind of long, but all I'm doing is giving my reasons. And we already know the first reason. What's always going to be the first reason? Okay, because it is up here. It's given. Now, it's because you did 8 times x and 8 times 2, which does give you 8x plus 16. That's great. Why is it doing that? Anyways, so yeah, that's distribution. So I call it the distributive property. All right. And after that, now, what changed from step 2 to step 3? This is very important. Everybody, step 2 to step 3, what changed? Okay, so at the very end, 16 and 3 went away. Now it's a 19. Well, what do they do with 16 and 3? They added them together. Now, they did not add something on both sides. They just took something on one side and then kind of put it together. What's that called when you do that? There's a phrase on the front side of our notes that we have for that. Combining like terms. Thank you very much. Okay. So when you add numbers together on one side, when you're combining on one side of the equation, that's not addition property. That's combining like terms. Okay. Now, if you add it on both sides, that's the addition property. But one side, combining, is called combining like terms. Okay. Combining like terms. Okay, now from step 3 to step 4, I had 2 x's, now I have 1 x. They must have got rid of one. They must have got rid of the smaller x, like I taught y'all. Okay, so how do I get rid of a positive 5x, the smaller x? Subtraction, right? So, they did minus 5x here, minus 5x here, and they got 3. That makes sense. 8 minus 5, right? So since I subtracted on both sides, what do I call that? Subtraction property. Okay, next step. X is on the right side. I need to get rid of my loner. What's the loner? Sorry, on step 4, what number is the loner? On the side with X, it's 19, okay? So you think of where's X? On the side with X, 19 is the loner. It's a positive, so what do I do? Yeah, minus 19. And isn't 7 minus 19 negative 12? It is, okay? So since I just subtracted on both sides, what's my reason? If you subtract on both sides, what's your reason? Okay, subtraction. Now, we had that on our last step, and we're doing it again. That's fine, okay? You can subtract twice as long as you need to do those steps, right? All right, number 5, if I'm getting rid of that 3, right, step 5 to step 6, the 3 goes away. How do I get rid of that 3? It's hard to do notes on your phone. Hey, Amari Cooper. You off the phone? Thank you so much. Divide is correct. So when I divide, I get negative 4. That's great. And since I just divided, what am I going to write? Thank you. Division property. Do you see how you're just telling me your steps? Okay. Now, this is new from the front side of our notes. When I have you remember from the front side. What do you call the property that just flips them over? When you think about something as you can fold something in half, you see on both sides, you can flip it over, it's the same. That's the symmetrical property. Okay? So why on earth are we doing the symmetrical property? Because we like to have x on the left. So when you have x by itself and x on the right side, one last step, flip it over. It's a symmetrical Okay. Cool. That is our first two examples. Now, time is limited. I want you to try number 3. This one has no training wheels. You have to write your own steps and give your own reasons, but I want you to try that on your own right here, right now, for me, please. Okay?